Greetings, math people. Today I want to visit a very special problem. So it was a few years ago when some of my students had asked me about this problem, like right before class. They said, Mr. Arrington, what's the integral of x to the power of x? And it wasn't a problem I remember ever doing. And in my mind I tried to work real quick the way to solve it, and didn't really come to me. And I had to, give the lesson for the day. So I said, I don't know, and kind of went on with my presentation for that class, and didn't really think much else about it until I came home that night. And when I came home, I went ahead and looked at the problem, and though it was a little peculiar, I kind of found the solution rather quickly. So today I was kind of thinking about the problem, and so I decided to solve it in this next video. So the problem is the integral of x to the power of x. Now, it's not as nice as it seems. It's quite devious, actually. So what you don't want to think is this is a variable raised to the power of a variable. So it's not like a to the power of x, whose integral would just be ax, a to the power of x divided by ln a. And it's not like x to the power of a, whose antiderivative would just be x to the power of a plus 1 divided by a plus 1. So it's not one of these simplistic examples. It's a little more devious, if you will. So as I was looking at the problem and thinking, of course I'm running through my mind, I'm thinking about u substitution. And if you look at a u substitution, you're going to make u equal x. You're going to have u to the power of u. That's not really going to do much for you. And I thought about integration by parts. But if you integrate by parts, you don't really have two different functions. You can make u equal x to the power of x and dv equal dx, but it really doesn't accomplish much either. So I thought about the way I did it, and I kind of remembered that I rewrote this expression. So I remember that was the key. So I want to rewrite this expression, x to the power of x, in a way that may be easier to solve. So let's say we let y equal x to the power of x. And let's say we rewrite this in logarithm form. So in logarithm form, it would be log base x of y equals x. And if we apply the change of base formula, x would be ln y divided by ln x. And if I solve for ln y would be x times ln x. And then to put it back in form of y, I would make these exponents of e, and e to the power of ln y would be y, and then this would be e to the power of x ln x. So this is the form I'm looking for. So this is a better form. So this expression, e to the power of x ln x, is the exact same thing as x to the power of x. If you think about the properties of logarithms, this x in front of the logarithm can become an exponent, and so this can turn into ln x to the power of x. And if you have e to the power of ln x to the power of x, you just get x to the power of x. So this expression is the exact same as x to the power of x, but maybe it's a little bit better form to attack. So instead of integrating x to the power of x, I'm going to integrate it in the form of e to the power of x ln x. So that's the form I would like to attack. Now, it's still not the easiest problem in the world to do. So again, the same thoughts cross my mind. U substitution, integration by parts. And the thing that looks like we might be able to do is integration by parts. So I'm going to try to solve this using integration by parts. And what I'll do is I'll make u equal e to the x ln x and dv equal dx. Okay, so we can easily take this derivative. It's a little chain rule, and in the chain rule, some product rule. So du, so I'm doing chain rule, so I'll take the derivative of x ln x, so that's product rule, so I'll take the derivative of x, which is 1 times ln x, which is ln x. Then I'll take the derivative of ln x, which is 1 over x times x, which is 1. And then that'll be multiplied by e to the power of x ln x. So that's that derivative there. Of course, if dv is dx and we integrate, then v is x. So v equals x. So far looking fairly good. And so we're going to apply the integration by parts formula. So we're going to multiply u times v. So u times v would be x times e to the power of x ln x minus the integral of v du. So the integral of v du would be x times e to the x ln x times ln x plus 1 dx. So again, I was doing this earlier today. I got to this point. I felt pretty good, but I was stumped a little bit here. Now what went through my mind is I could solve this using u substitution. So that was my thinking. To solve this problem, I really just need to find this integral. So I thought about u substitution, and I thought about making u x ln x. Now again, if u is x ln x, its derivative du would be, again, it's the derivative of x, which is 1 times ln x, plus x times the derivative of ln x, so that's x times 1 over x, which is 1, dx. And when I thought about it, I started feeling pretty good, because look, du is ln x plus 1 dx. So all of this will be du. It's taken care of. U is x ln x, so this will be e to the u. But then the problem, it was looking real good. The problem was this x that was left there. So the x kind of messed up my u substitution. And I tried to think of creative ways to get rid of the x. I couldn't figure one out. So I said, well, if I can't do u substitution, perhaps the key is integration by parts. So I attempted integration by parts. Now again, to solve this problem with a solution with elementary functions, I just need to find this integral. So I'm almost there. Now remember what I'm trying to integrate. So to restate the problem that was given, so the problem was integrating x to the power of x, and we rewrote x to the power of x as e to the power of x ln x. And so what we have here is the solution that's developing. So this so far equals x e x ln x minus the integral of x e x ln x times ln x plus 1 dx. So this is the problem, and to solve it, all we have to do is figure this guy out. Again, u substitution didn't work, so we're going to try integration by parts. So to do this with integration by parts, you would probably make u equal x. So again, this is where I'm at. So let's make u equal x. And let's make dv, equal e ln x plus 1 dx. Now when I approached it in terms of integration by parts, I got a little bit excited, because the problem with doing this with u substitution was this x that was right here. But when I do it by integration by parts and I do this separation, there's no more x there. So I got pretty excited. And so I did the rest of integration by parts. And it started developing very nice. If u is x, then that means du is dx. Nice. If dv is e to the ln x, e to the x ln x times ln x plus 1 dx. And again, if I think about u substitution, I'll make u, we can do this one mentally, it's pretty straightforward. I'll make u equal x ln x, which means du would be ln x plus 1 dx. So this becomes e to the u du. Beautiful. Of course, the integral of e to the u du is e to the u. The excitement begins. So this is just going to be, v is just going to be e to the power of x ln x. So at this point, I got pretty excited. It seemed like everything is solved. So let's apply integration by parts. Now, recall, there's a minus sign in front of all this. So everything I'm developing here is this integral right here. So that's what everything I'm developing right now. So we do integration by parts. So we have u times v. This is x times e to the x ln x. And again, there's a minus sign in front of this due to the minus sign right here. Now, normally in the integration by parts formula, there's a minus sign here, but due to this minus sign, it's going to become a plus sign, and it's plus the integral of v du. Well, v is just e to the x ln x, and du is just dx. So this developed quite nicely. So to write the rest of this, so I'm just going to rewrite this expression, and instead of this, I'm going to plug in this. So we have the integral of e to the x ln x dx equals x times e to the x ln x minus x times e to the x ln x plus the integral of e to the x ln x dx. And then I realized something. So look what happens here. You have x times e to the ln x minus x times e to the ln x. That cancels. You have an integral of e to the x ln x dx on this side, and an integral of e to the x ln x on this side. That cancels. And then it all came to me. There is not a solution with elementary functions for this problem. So the integral of x to the power of x dx does not have a solution utilizing elementary functions. And then I thought back to, but didn't I solve that when the kids asked me that a couple years ago? And then I remembered, they weren't asking me to integrate x to the power of x. They were asking me about the derivative of x to the power of x. So sorry to waste your time, but this one doesn't have a solution with elementary functions. And so that's still a question mark. Good night.